with the square size cut up, so you could type it as a square size. But I'm going to give it a variable. I'm going to call it x. And then what we're going to start with, maybe 1 centimetre chopped out. And then the formula equals the cell above plus 1. And so you're going up with a square of size 1 chopped out. Okay, we'll leave that there. So if you chop out a 1 centimetre, then this is the length of the base, and this is the width of the base, and this will be the height of the box, and this will be the volume. So we're going to try and feed in some formulae here. So the length will be 20 minus 2 times by the number here. Oh, we need to start with an equal sign. Equals 2 times this number here. That's great. Then we can grab that and drag it down, as that all fits together well. But I'm going to just change this a little bit, because I'm actually going to highlight all of these numbers and I'm going to name them. I'm going to name these variable x. So if we click insert, it's data, and data is named ranges. And so we're going to call this x. Now what we're going to do in here, we're going to actually construct a formula which deals with x, the input. So here is equals 20 minus 2 times by x. I'm going to drag that down here. Okay? And the width is also equal to 20 minus 2 times by x. And notice it highlights all of these numbers being x. And we drag down. And the height of the box is equal to actually the size of the square chopped out. So it's equal to x. And then the volume is equal to the length times by the width times by the height. Okay, so you can see the volume kind of starts to go up and then starts to come back down again. So we'd like to see what this looks like as a graph. So click and drag down and highlight, then press Command and click and highlight here. So you've highlighted 2 columns, and now you can go to Insert, Chart, and you want a scatter graph. So you're going to have to scroll down to a different chart type here. And there's a scatter graph, and that's kind of what we expected. Quite interesting down here what happens when it bounces back up. So we'll talk about that in a minute. And then we can actually do customization. And the title would be volume of a box. Volume of a box for various heights. And then we scroll down here. And the horizontal axis, this would be the size of square cut out. And drop down, left vertical would be the volume. Should really put the units in. This is centimeters cubed. Doesn't really do a little power up sign. And then if I go back to the horizontal, this is in centimeters. And that should do it. So now that's our graph, which is kind of cool. But what's going on down here? Why is it bounced back here? Well, if you look at this one, as soon as we chop out 11 centimeters, we've got a length of -2. So obviously we can't quite go past a length of 10 to chop out. So that's quite good. So you can see that roughly the maximum is about here. That's an aeroplane going overhead, sorry about that. So we'd like to zoom in a little bit further into here and see what's going on really. We could also transfer these numbers and put them into Ti-Nspire, and might give us a bit more accuracy. Okay? But I want to show you another feature here, because we kind of know that the maximum volume is occurring somewhere in the region between a chop out of 2 and a cut out of 4. So these are the kind of important numbers we're seeing. So if I go and actually create something a little bit different, so I'm going to put start here, I'm going to put step here, and the start is going to be the starting number here for the x cut out, and the step is how much the step size goes up. The step size here is currently 1. I'm actually going to change the start number now to 2 and the step size to 0.5. But I'm going to highlight this and I'm going to name this start, and I'm going to have a look here, and I'm actually going to change this one here. I'm going to change this to, it's going to be H2. I'm going to name this one step. Now over here, I'm going to press a little formula. This is going to be equal to start. Notice this number gets highlighted. And in here I'm going to press equal the cell above plus step. So this will add whatever the step size is to the number above. And I'm going to drag this down. Then I'm going to unhighlight all this. Now just look what's going on here. We're actually just zooming in a little bit on the most important features of the graph. Yeah. So we now can see, if you look back at this table here, this number here, it's looking like maybe 2.8, 3.5. So if we just click off there, we go over to here, the maximum volume is now occurring somewhere between 588 and 576 here. So it looks like I'm going to start now at 3 up till 4. So I'm going to start now at 3. And the step size I'm going to change to 0.1. So this is like a real search machine now. So we're having a guess and check to find out where the maximum volume might be. Yeah. And now you can see that it looks to be going over 592.5. So when you look in the volume answers here, this is the biggest one at the moment. So somewhere between 3.2 and 3.4. So now I'll change it to 3.2 as the start size. And now we'll go up in 0.05. Okay, so this is just a way of zooming in and zooming in and zooming in to see where the actual max volume might be. Now, of course, we might not need this level of accuracy. I mean, to 1 decimal place, I would think that's accurate enough. So let's have a look. To 1 decimal place, let's just look down here, which is the biggest volume. 592.58, 592.548. So this looks to be just about the biggest volume, round about 3.35. Yeah. And we could check it even further, and we could just go crazy and just go 0.01, and we can start at 3.25. See how interactive everything is. So now we can dig down a bit deeper. 592.57, 58, 59. Okay, so 592.59, and that's for about 3.33. That's probably enough, really. You could transfer these numbers to Ti-Nspire, and that's great. But actually, what we're going to try and do is we're going to try and craft a formula for volume with respect to what's happening with the x cutouts and the length and the width and the height. So when you're crafting a formula for this, we know that the volume here, we got the volume by doing length times width times height, but the length was just 20 minus 2x, and the width was 20 minus 2x, and the height was just x, and this gave us the volume. So you've actually got a formula for volume. Volume equals x times 20 minus x, and you put that in brackets. And that would be the formula for volume. So we'll transfer that to Ti-Nspire now and see what happens. So in here, we're going to insert a graph. We're going to type in the function. It's x times by 20 minus 2x times by 20 minus 2x. Now for this particular piece of paper, the width and length are the same, 20. But you could change this to whatever width and length the paper you wanted. And I don't see much of a graph there. But of course, when you scroll back to the spreadsheet, it's always good to have some numbers to play with. You can see that we need to actually have the y-axis going up to 590. So go back to Ti-Nspire. The quickest way is to click on the actual number here, double click on it. Let's change that up to 600 and see what happens. That looks better, but we don't need this -10 here. We can start at just -1. And notice this cuts down here at 10, the maximum cut size. Okay, so this is the point we want here, and then we know exactly what to do here. You can click and drag the graph to make it a little bit, to make it fit however you want. Menu, analyze graph, maximum. You have to choose a little bit before and a little bit after, and there you've got a particular result here. Okay, and that's that.